give you some background on what we're doing is we're working with our client, who's a surgeon here at the University of Missouri with a laryngeal specialty, and we are redesigning the way that the implant that he's using is being manufactured.
Previously, there was a device that was easily carved out of silicone, and it had like the pre-made measurements and everything. That was discontinued, and so now he just has to take basically just a big block of silicone and carve it himself.
So our goal is to cut down his time. I had the opportunity to observe a surgery, and I would say we are saving him, if all things go according to plan, 45 minutes off of this surgery.
So now that we have decided what design we're going to move forward with, the next thing we did was go to the computer lab and make our design in SolidWorks, kind of just like the baseline model for what we were thinking. We still have some things to add now that we've really talked about it more.
Our initial design looked a little bit like a paper cutter, which you can see on our board. This was selected using a best of class chart where we looked at cost analysis, sustainability, as well as the ability to create durable right angles, which is a big issue for this specific type of implant. Unfortunately, after additional testing, we looked at different blades at different angles and found that it simply wasn't providing enough force to not shear the block, which is why we ended up using this design. Essentially, we found out that the flat blade wasn't going to provide enough force to both puncture and cut the block without shearing it. But after some more testing, we did find out that a point on a blade will effectively puncture the block and then allow you to cut through it with much more ease. So we implemented a triangular blade into our design and adjusted the base accordingly, and we have a guillotine.